Welcome to session 2 of You're Doing It Wrong. It's a tutorial series where I teach certain skills and different programs that will save you time and energy going forward. I started this tutorial series because I understand that technology is moving at a breakneck pace and it's getting more difficult to keep up with all of the different advances and changes in the technology. And so this tutorial series is to help everyone increase and better their workflow so they're working smarter and not harder by learning the best ways to get things done. I believe that a designer should be versed in all tools available to him or her, so they are never bottlenecked by the lack of knowledge of any specific tool, so it is important to be in the know. This session is today, October 4th. 2 weeks ago was the 20th. That was on Photoshop. That's available online. The next sessions will be October 18th on Grasshopper and parametric design. November 1st will be on rendering with V-Ray, 3ds Max, and other rendering engines. And November 15th will be on publishing, so working with InDesign, making publications and books. So keep these on your radar. All of them are 7 to 8:30 in room 103B on Wednesdays. So these are the session breakdowns. This is session 2, so vector interoperability. So we're going to be working with Illustrator, Rhino, and AutoCAD. And that's working with an integrated workflow, all things vector, all things DWG, the pros and cons of vector graphics, and also making better drawings and diagrams with your vector work. So the 3 softwares that we're going to be talking about are Illustrator, Rhino, and AutoCAD, and how you can actually jump from one program to another using vector information. So let me talk about the difference between raster and vector. This is a very important distinction, so you know what you're doing with your files. Raster files work with pixels. Pixels are little squares of color or light that show color information. And when you get enough of pixels together, you compose an image. So every screen that exists is composed of pixels, and the more of them you have, the higher quality the image is. The thing about raster is that pixels are only scalable so much. You can't get more information once that information is lost. You have to either get a new image or recreate that image. And that's different from vectors. Vectors, instead of being pixel-based, are actually math-based. It's actually a math equation that is generating the line work that you see in your drawings. And that makes vectors easily and infinitely scalable, and make them as small as you want or as big as you want, and they'll always retain their quality. So what is a vector? A vector is a mathematical equation that defines magnitude and direction. So a magnitude is basically from point A to point B, and that's the length of the vector, and the direction denotes where it's going. So 2 points typically define the confines of a vector. Both points are in space with an x, y, and z, and it's infinitely scalable. So in Illustrator, vectors are defined by an anchor, which is a point, a line, which is a connection between at least 2 points, a polyline, which is 3 or more, a closed shape, which defines a closed boundary that could be any shape, triangles, squares, rectangles, circles, etc. And that shape can be filled in. Working with vectors in Rhino, it's slightly different. And so Rhino uses what's called NURBS modeling, which is short for non-uniform rational basis spline. So that information is irrelevant. What you need to understand, though, are the basic shapes that NURBS creates. So there are 3 basic shapes that define a NURBS. You've got a point, which is a location in space. It has an x, y, and z. You have a curve, which defines all types of lines. That is basically an infinite extrusion of points, right? So the very basic element of a line are point A and point B, but you can actually extract a point from any point along that line. And a surface is just an infinite extrusion of curves. So it goes from point to curves to surfaces, and polysurfaces are just the conglomeration of different surfaces. And so it's important to know that, I've got a surface here. That means I can extract a curve at any point along the surface. If I've got a curve, I can extract a point from any point along that curve, and a point, of course, is just a single point in space. And that's different from meshes. Rhino also works with meshes, but they're calculated differently. They're not calculated using NURBS. They're actually calculating using polygons, either with 3-face or 4-face. And so instead of working with points, it works with the connection of 3 points or 4 points, and that connects the mesh. And so that requires a different set of commands while working in Rhino. Degrees. So this is really important when defining vectors in Rhino, and AutoCAD does a similar thing. A single degree means the line will be straight. A 2-degree line means there will be 2 segments that define the control points, and it generates a spline that is an aggregation of those 2 degrees. And the more degrees that you have, the more curves the line can have, but it's less information than having an anchor point at each point along the line. So if you want to make a line that is an approximation between a series of points, you just need to increase the degrees that that line has. So when looking in AutoCAD, it's slightly different, but a lot of the same concepts apply. You have a vertice, which is what AutoCAD calls points. Same thing, X, Y, and Z coordinate. A line, a connection between 2 points. Polylines, multiple connections of lines, and closed shapes. So when we're talking about interoperability, it's important to know what file formats that different programs can understand and talk to. The main one is the almighty DWG. Just about any program you use in architecture school can read and understand DWG files, import them, and export them. So that means that you can go from an Illustrator document to an AutoCAD document, from Rhino to InDesign, from InDesign to Illustrator, from Illustrator back to Rhino. All of these programs using a DWG export can understand vector information. This is very important for some things that we'll be talking about later that will save you lots of time and energy. Some other file formats that deal with vector information, .ai files, so Illustrator, .rvt, which are Revit files, .dxf, which is just a slightly different .dwg format file, .sat and .obj, which deal with objects and meshes, which is important for 3D printing. .3dm, of course, those are Rhino files, etc. But the DWG is the one that matters the most and that the most programs can understand. We're going to start here with some simple Rhino geometry. I'm going to create the 3 basic Rhino forms that define the NURBS modeling that it does, and some interesting things you can do with them. So I'm going to pop in the top view here, and I'm just going to create a point, and there are 2 ways to create a point, either by clicking the point command in the standard tool set and placing it, or typing in point and placing the point that way. Either way works just fine for what you want to accomplish. But again, a point is basically has 3 coordinates, an X coordinate, a Y coordinate, and a Z coordinate. And those 3 coordinates can be used to generate a point at any point in 3D space. So let's go ahead and generate a curve. Click on the curve command. I'll grab a point and give it a force, right? Or give it a direction and a magnitude. In this case, I could click or to define it at a certain location, or I can type it in to get a very specific distance, right, for my vector. There are a few ways to generate a surface. Either you can generate a surface from a closed curve. So if I create a closed curve, let me turn ortho off here. This is now a closed curve, which means it's not a surface yet, but I can define a surface within it. And the best way to do that with a closed curve is just to use planar surface, which is a command there. Planar surface only works when you have a planar surface, which means that it's flat. So you need a planar set of curves in order to generate that surface. So like I said, you can extract a curve from any point in that surface. And so oftentimes when you click on a surface, you'll see some of these lines here. These are called isocurves because they don't actually exist, but they're used to define the division or the quads of a surface. And you can actually manipulate those isocurves to get more divisions in that surface. So if I were to just create a regular rectangular surface here, if I click on it, I have 4 quads, which means that there are 4 vertices that define this surface. But if I want more, I can use a command called rebuild. And this allows me to increase the point count. You can see there is a U and a V here. U and V are basically the X and Y of a surface. And so X and Y are universal coordinates for the world of Rhino, but U and V are coordinates for that surface. So if I want to increase the number of points or divisions in the U direction, I just type in a bigger number for U and hit preview. And you can see now I've got 10 divisions here. I can do the same for the V direction. Now I've got 10 divisions in the V. And so I can go ahead and click OK. And now I have isocurves that define a 10 by 10 grid. And if I were to turn points on now, so points on, just a command, I now have more control points to define what the surface will be. And I can actually use these points to modify the surface in interesting ways. And so note that when I'm doing this, right, it's modifying the isocurves that are there, and I can still extract a curve from any point along the surface. So this is the basics of NURBS geometry. I'm going to talk about meshes really quickly. So if I wanted to convert this to a mesh, I'll use a mesh command. It's going to ask me what surface to convert to a mesh. I want to convert this one to a mesh. I'm going to click OK. And you're going to see that the mesh surface is done a little bit differently. So as you can see, it kind of straightened out my surface here versus the NURBS surface, which is a little bit more rounded. The mesh surface used, like I said, the planar faces, and in this case, it's a quadrangular mesh, so it uses faces that have 4 corners on them. But meshes are handled differently within Rhino. And last but not least, I'll talk about a polysurface. So I'm going to create a box here. And all objects in Rhino that aren't meshes are polysurfaces. They're a conglomeration of different surfaces that have different faces in the X, Y, and Z direction. And so this box is a conglomeration of 6 different surfaces that I can then extract and do different things with. Okay, so let's say you've got your vector work in Rhino worked out and you want to start making a drawing in Illustrator. There are a few ways you can extract the vector information from Rhino and put it into Illustrator. So I'm going to switch over to another drawing of mine. This is a tower I was designing for fun. You're not an architect yet until you design your own building for fun. So let's say I wanted to extract one of the units, and I wanted to add one of those units into Illustrator. So I'm going to create a view. Let's do like a really simple perspective view of this drawing here. Some things that are really important to note. When you're exporting from Rhino, there are 2 ways to do so. There is the export command, which exports all the vector lines of everything that you have selected, which could potentially be good or could lead to a very messy drawing. Or you could do what's called a make 2D, which takes the exact vector information that's visible and invisible and separates them for better layer work. So in this case, we're going to use make 2D. So it takes all of the 3D vector information and flattens it for our drawing use for 2D. And I'm going to show you some things that are really important to note when you're making 2D. And one step that I haven't done yet, but you should always do before making your drawings, and I'll show you that in a second. But let's say I wanted to make 2D. When you initiate the command, if you don't have anything selected, it'll ask you to select something, of course. In this case, I had my unit selected first. Some settings to note. You can actually export a 4-view make 2D at the same time by checking 4-view. But I'm just going to keep it on current view. You can export show tangent edges, show hidden lines, which in this case I do, which could make for an interesting drawing, where all the lines that are behind closed planes can be used differently in your drawing. Show viewport rectangle, which is very important for working drawings. It allows you to be able to match up different exports correctly and a lot more easily. So always have show viewport rectangle checked. Maintain source layers, which is good for clarity and your workflow, so have that always checked. and you can customize which lines are visible, which lines aren't. Here we go. So there's my Make 2D. It's given me the vector line work of my unit in perspective. And before I deselect it, I'm going to go ahead and export it. So type in export. In this case, I could either save it as an Adobe Illustrator file or an AutoCAD drawing or DWG. I'm going to export it as both and show you the difference between the two. I'm also going to export it as DWG. Default settings are fine, but if you want to be safe, just downgrade it to a 2004 export, which ensures that any program you bring it into, it will work. And I'm also going to do an export of the drawing without doing a Make 2D to show the difference between that. And that's why I created a named view, just to make sure that the view is exact. So I'm going to select my object and go straight to export. Okay. So now I have all of my exports. I'm going to do some interesting things with them, but we're going to go ahead and import them all into Adobe Illustrator, just to show you the differences between the different export methods and how we can move forward with that. This is coming later, so we'll talk about that in a little bit. So we're going to go to File, Open. We're going to locate our files and import them. We'll import the AI files first and then show you some of the settings that happen with the DWG. So when you go to open a DWG, since DWG files are usually created in 3D modeling software that has a 1-to-1 scale, Illustrator will ask you what scale you want to bring the vector line work into. It's probably most likely best in this case to scale to artboard, because if you import it at the original scale, most likely it'll be too big for the artboard and the drawing area. So importing it at a scale is really important to note when you're working with DWG files. If you click on scale, you can actually enter in the scale you want to bring it into. This is hit or miss. I've had varying degrees of luck in terms of getting the scale right, so most likely I do the scaling after the fact, after the import. In this case, we're just going to scale to fit to artboard and hit OK. Alright, so the differences between the three files. The file I did a Make 2D on that I imported as an AI file has some things going on here. So all the layers came in as the original layers that were exported. The lines in the layers were white in Rhino, so they came in white in Illustrator. So we're just going to go ahead and select the layers and change that. And these are all the hidden layers that I was talking about earlier, which are line work that are behind visible walls. And so I'm going to grab all the hidden layers, move them to the bottom because layer order is important. Whatever is on top will show above other lines, whatever's on the bottom. So keep that in mind when working with your Illustrator files. All the lines are white and the layer colors are also white, so I can't really see anything. So let's go ahead and change the actual lines to a color we can see. In this case, since they're hidden, I'm going to make them a nice light gray. So they've shown up, and now I'm actually also going to change the layer color, because white layer colors, black layer colors, and yellow layer colors are trash because you can't see what you're selecting. So always change the layer color to something else, to any other color besides those three. So I'm just going to quickly change these all to a different color so I can see them, which is important when working. I'm also going to place all the hidden layers into a folder for layer organization. It is always important to be organized with your layers so you can find things later. cannot tell you how many files I've seen that have layer 300 in them, and they have no idea what's in it. I'm going to make these layers a lighter line weight or a smaller line weight so they fade more to the back. I'm going to do the same thing with my visible lines, which right now are also came in really light, and some of them came in white. So let's go ahead and set them to a heavier line weight. Let's turn down the line weight. Okay, so there's your vector work that you've exported, right? So this is the export from Make2D to Illustrator. If we go over to the export Make2D to AutoCAD, we get slightly different results. There are no hidden lines in this export. It exported them as the layers that they were in Rhino. And so the block layer in Rhino was white, so all the layer lines came, or all the vector lines came in as white. So we're gonna change them to black, just so they show up, and also change the layer color. And so this export to, actually, sorry, this is the drawing to DWG with no Make2D. So this was just the raw export. It exported every line. There's no distinction between what lines were behind and what weren't. And we also get some of the isocurves that I talked about earlier as well, which denote surfaces. But this method requires a lot of cleanup. So I always do a Make2D export to save a lot of time later on. You can tell the difference instantly between the two drawings, the two drawing exports. And the Make2D export to DWG came in slightly different as well. We do have the hidden lines, but they didn't come in white because the layer colors were white in Rhino. So this requires a little less cleanup, but the best method in this case when working with vector files from Rhino to Illustrator is Make2D, export to AI. So that's bringing it in. Let's say you wanted to work in a different method. Let's say you already have an Illustrator file that you're working on, but you realize the shortcomings of Illustrator, because Illustrator has a lot of shortcomings, that a program like AutoCAD or Rhino can do better. So this is starting to get into the interoperability. This is a portrait that I worked on in first year. This is the photo of the drawing. It's really low quality, so I wanted to get a nice vector version of it. So I popped it into Illustrator. I retraced all the lines. It took me about 2 hours. So I got this result, and I was working on a poster for an IAS Vice President run that I did a few years ago, and I extended the lines of my face to the edges of the page. To do that in Illustrator would take another 2 hours to grab each one of those lines and extend them, because Illustrator doesn't have good extend or trim commands, right? So huge waste of time to try to do it all in Illustrator. But I do know that AutoCAD has amazing extend and trim commands. So I'm actually going to export my lines from Illustrator, put them in AutoCAD, and then bring them back into Illustrator to save 2 to 3 hours of time. One thing to note when you're exporting vector lines or a DWG from Illustrator, you need to make sure that your exported file has no image information in it, because that image information or raster information, when brought into AutoCAD, will mess things up. So I usually tend to open up a new document that's the same artboard proportions as the one I was working on before. And the reason I'm doing this is because I do have that image file in here. I could, of course, delete that image file, but I don't want to. So I'm just going to create a new document here, and I'm going to paste in the lines that I want to bring into AutoCAD. So I'm going to go ahead and select them. Make sure that the artboard that you're selecting the information from is selected. I'm going to hit Control-C to select, go to the new document, click on the artboard, and hit Control-Shift-V, which is paste in place, which is really useful. I'm also going to draw a boundary for the page here, and this boundary will be important for the extend and trim features in AutoCAD, and will also help me reposition the drawing once I bring it back in. So always have a reference boundary that you can use so you're saving time. So now I only have the vector information that I need to bring in AutoCAD. I don't want to bring in any more than I need. So I'm going to go to File. I'm going to go to Export and Export As. I'm going to make sure I check AutoCAD Drawing. Save that DWG file from Illustrator. Make sure all of the settings here are correct. In this case, they are scale 1:1, true color, etc., etc. Okay. Open up my file. Okay, so here's my vector information now in AutoCAD. I'm going to select it all and turn off all of the overrides, all of the information overrides, just, by layer. So now I've got my vector information in here. I'm going to use AutoCAD's excellent extend and trim features to extend the lines to the border of the page and then bring this back in Illustrator. So I'm going to select the boundary curve. I'm going to type in extend. And then I'm just going to grab all my lines and extend them all. So in a matter of minutes, I've saved what would have taken me several hours to do in Illustrator. So it's just understanding the strengths of each program and utilizing them, and understanding that vector information can be moved back and forth between the programs, which is pretty great. And I'm sure there was a time when this wasn't possible, and some architect in Idaho complained about it to Autodesk and got it done. So thank you to all the architects and designers who worked out all the kinks for us. But just understanding how all of this works can save you lots of time and potentially money. So now we've got some of the extensions here. It looks like I got some of the lines to go in the opposite direction, which is fine in this case. But now I'm going to go ahead and re-save this as a DWG. So we're going to go ahead and hit save. I'm going to go down to 2007, which is a back save or an older version of DWG that Illustrator should be able to understand. Give this a different name, not override the original version. Okay. Back to Illustrator. Open. In this case, I want to keep it at original size, since it was the original size 11 by 17 in AutoCAD. Okay. Now I have my extended lines. In 3 or 4 minutes, I saved several hours of work just by understanding the differences between the vector programs and how to use them more efficiently. So it's things like this that once you start getting down, it will save you a lot of time going forward. So I got my name sliced here, and the way I did that was just working with some of Illustrator's conversion commands. And so text information is different than regular vector information, but you can actually convert anything that you type into an outlined stroke. So this is my name in text. I'm going to go ahead and capitalize it. If you go over to Object, you'll see a series of commands here that are really powerful. In this case, I'm going to expand my text, and that will turn it into vector shapes that are no longer editable by the text command, but it allows you to do a series of modifications to that now shaped version of your text. So when I hit expand, it's going to ask me if I want to also expand the object and the fill, and I want both checked. And so now you can see that the text here is no longer text, but vector shapes that I can then do some interesting things with. So For example, if I wanted to cut these out of another shape, and I put this text on top of it, I can actually use the Pathfinder commands, which you should get used to with their great set of commands, to cut my name out of the shape. All right, so that's one thing I can now do with that text information once it's been converted. In this case, what I did now was I took a slice of this information, a line here. I selected all the text information below. Actually, you select the line that you created, the vector line. You go over to Object, Path, and go to Divide Objects Below. And that cut the vector. I'm going to ungroup this so you can see it, but it cut the vector information into two pieces. And so I grabbed all the ones behind the cut and just shifted them down. Some other cool things with Illustrator vector work that are important to note. So let's say you're working on a graph or a diagram, and that graph or diagram has a scale to it. So a fast way to build a scale in Illustrator would be to draw your respective vertices of your axes. So let's say we have our y-axis here. Let's say this is a number of people that live in Knoxville over a certain period of time. So I'm going to draw my first vertice here, and I'm going to actually copy this a bunch of times. So Control Shift V. So let's say this is now my vertical scale. They're not even yet, but you can use the align commands to quickly do that. And so I'm going to use the equal spacing by center. And now those lines are evenly spaced, and I can use them as a scale for my drawing now. So, this could be represent, 1000. But again, you can use this for any information you have in Illustrator to align them and space them evenly. So that's a pretty useful tool there. So get used to the Pathfinder tools, get used to the align tools, get used to commands like blend. I'll show you really quickly. Okay, so let's say I have two curves here, and I want all the resultant curves between curve 1 and curve 2. You can use a blend, which will create all those different curves. So I'm going to select both objects, and I'm going to hit blend. Actually, I'm going to go to Object, Blend, Make. And then that creates one resultant curve between the two, but we can go ahead and go back to Blend and open up its options. You can have the orientation be all vertical, no matter what the curve is, or you can have it be aligned to the curve or perpendicular, which is basing it off the normals. Instead of smooth color, I'm going to use specified steps, and you can type in the number of blended curves in between there. And so now you have all the resultant curves there. So that's another interesting thing you can do with vectors in Illustrator.
Another factor you have to consider when working with vectors in Illustrator is the level of detail and the number of anchors in each line. So I have here a contour map. It's pretty small, but each contour line is comprised of hundreds of different anchors. Imagine if you have acres and acres in your contour map, and each line has hundreds and hundreds of anchors. This tends to slow down Illustrator a lot. So in order to combat this issue, you want to go ahead and select your contours, go over to Object, Path, Simplify. You want to set your curve precision to 99% to keep it as close to the original as possible. When you do this, you can note that the lines are getting reduced, or the anchors in the lines are getting reduced by a lot. So you'll see that it's going from 16,251 points to 4,399 points, which is a lot less points for Illustrator to compute, and it will move a lot faster while retaining the detail of that line. So I'm going to go ahead and hit OK, and you'll see that there are a lot less anchors per curve here, which means Illustrator will run a lot more smoothly.
Again, the next session will be October 18th on grasshopper and parametric work. So that should be a lot of fun, so you can start understanding how to make smarter drawings that have a lot of data and information embedded in them. Thanks for coming, guys. We'll see you in the next 2 weeks.
And now you're doing it right. Be sure to check out the other You're Doing It Wrong sessions. Thanks for watching.